Hi everybody, welcome to our next project. So I started editing this video and realized a couple of things. Number one, it was getting too long and tedious to edit all in one clip. And second of all, in the center of the video, I did a little thing where we did some transistor testing that I thought might be a useful reference video. So what I decided to do is I'm going to split this first part up into a couple parts. 2 or 3 parts, and then continue on from there. So if it kind of seems a little out of sorts, that's why. The other thing is there was a lot of activity at the house, people over and everything in the background. So had the air conditioning running, it was really hot for a couple days, and then it rained and stormed another day. So there's a lot of background noise, so you'll have to forgive that. It is what it is. Anyway, enjoy the video. I'll announce what it is in the next clip here. Take care, and we'll see you soon. So, of course, any of you that are regular viewers of my channel know that everything has to come with a story on this channel, doesn't it? And this one's no exception. So the owner of this, who is a friend of mine, who is an avid collector, found this and was very excited about going out and purchasing it. And when he spoke to the owner said, this thing is in extremely good condition. It works like brand new. It has never been recapped or anything like that, but it works perfectly. And if you come over, I'll demonstrate it for you. So of course, my friend got over there and they hooked it up to a set of speakers, he said, and he hooked up the preamp, which we're also going to do the preamp in another video. Turned it on. Everything looked good. And then there was a big billowing puff of smoke, and that's all she wrote. And I guess the look on the owner's face was absolutely priceless, according to my friend. So this is going to be pretty exciting. I just want to see what happened that day. So we're going to try to go back in time now, take this apart, and try to backtrack and figure out what happened when they plugged this in to test it that day and it went up in a puff of smoke. So what we have here is an SAE, Scientific Audio Electronics, and we did have another piece of SAE gear on the bench. It was that tuner, the Mark 6 was it, I think? The one with the really cool Nixie tube display. And this is a Mark 3 CM, and it is a 400 RMS. I guess that means 400 watts per channel. This thing weighs a ton. It has dual power supplies from what I can see in there. I haven't taken it apart. I don't even have a schematic yet. But I can see 2 great big power transformers. So this looks like this is going to be a really fun project to work on. So if that sounds interesting to you, stay tuned, and that's what we're going to be doing. Okay, I have the screws out, and we'll do the big reveal and see if we can find out where the smoke escaped from. Wow, look at that. Well, it kind of smells a little bit charred, but I sure don't see anything. And the first thing that strikes me is take a look at these output transistors here. The only thing is they're not output transistors. Those are the drivers. Back there, those are the output transistors in there. It's crazy. This thing's driver transistors there's 6 of them per side, and they're as big as the output transistors on that Lafayette receiver that we did a while back. So I think I can definitely say this amp was designed to go balls out. You know, balls out.
Those balls are out all the way.
Steam engine, centrifugal clutch, you know. Come on, guys, get your minds out of the gutter. So, can you spot which fuse is different than the others? Yeah, this one down here looks like it's gone. So let's pop that out and take a look at it. Well, I would say that's a pretty impressive failure. So whatever smoked did so before this thing did this. So here's an interesting thing that I was just looking at. If you notice, there are two massive transformers in this thing. Look how big those things are. They're massive. And it looks, and again, I don't have a complete schematic for this yet. I have to kind of dig a little bit more. But if you notice, there are only two main capacitors for the power supply. And of course, you have your positive and negative, I would imagine, split rail power supply. So what this looks like is each transformer is for, in other words, instead of this being a dual power supply, this is a single power supply, but each rail has its own transformer. So your positive voltage and your negative voltage each have their own transformer, rather than this being a positive and negative for the right channel and this being a positive and negative for the left channel, or vice versa. That's really unique. I've never really seen anything configured like that before. The other cool thing, and I like this a whole lot, let me get this turned around. I have you angled now so it's a little easier to see. But if you look down here, there's a connector down here. And I read about this. This is a unique thing on the design of this amplifier. So you can take these screws out here and here and down here, and then this board will unplug from a board that's down here this way, and this board down here that runs in this direction connects to all your output transistors, which are right in here, would be your output transistors, and there's a little cover over them. So all this is modular and can come apart. So I think the first thing I'm going to do, with the fuse blown that bad, there must be a pretty nasty short in here, and I'm not sure what it is, but I'm going to get this board out of here first. And it looks like there's been a little bit of work done on them, at least to the point where it looks like they've tried to solder these pins. They're supposed to be plug-on pins, but as you can see, they've been soldered on. So we have to remove those. And then we should be able to get this board out here and kind of see what's going on. And after taking out a bunch of screws from the top and bottom, it will come apart just like this. And I'm going to kind of move things around so that I can get to them easier. And then I'll be back. So we're now looking at the view below the heatsink. So these are the output transistors, and you can see they're coming in from the top of the heatsink. And here's your little relay for the protect circuit. And you can tell this has definitely been apart before. And just looking at the screws, it looks like people have been in this more than once maybe, because they're really kind of boogered up. And I see tape and things like that, so definitely this has been worked on in the past. And I don't know, I don't see, well, yeah, some of this stuff looks like it may have been taken out and put back in at some point, because the solder looks different than some other spots, but I'm just going to have to look at that a little more carefully. We really can't power anything up right now until we know where the shorts are and everything. So I'm just going to kind of give this the once over, and once we do, we'll put it back together and we'll see what we get. Well, the more I look at this thing, the more bad things I find. Why should I be surprised, huh? Any of you that have watched this channel for any period of time, you pretty much know everything has to be a mess. So this has had a lot of work done on it, the more I look at it. And so we're doing some what we just call static tests, where we don't put power to anything, and we just, one thing we have going for us, this is a stereo amplifier. And essentially what it is two identical mono amplifiers sharing one power supply. So we know that when we do some comparative testing, we can test one channel and then test the same thing on the other channel, and technically they should match. So you should have the same reading on each side. So right off the bat, I noticed that, for instance, this resistor, which is, it's a 400 ohm resistor, and it reads pretty close to 400 ohms. When I go to this side and check it, it reads a dead short. All the other ones seem to be reading the same. So that tells me at least one of the outputs is probably shorted. But the scarier thing is, I started looking at, the soldering work was pretty good on this, so for the most part. But when I look closely, here's the one channel. And I don't know if you can notice this or not, but you see these transistors here? There's one here and one here, and they're kind of stretched out. These have been replaced, and what this is one of those transistor packages where there's two transistors. They're thermally connected together. They're supposed to be thermally stable. They're coupled. This is not the way this amplifier came. These were added at some time, and the soldering job was okay, but one of the pins is not properly soldered, but I don't think that's the problem. If we look at the original, the way it was, and I don't know if I can get the camera around here and zoom in a little bit. If you look, and these wires are all the way, but if you look right here, here's one transistor, here's the other transistor. There are actually two discrete transistors here and over here too. So so we don't have the same transistors on either side. I don't know how big a deal that is, but you know me, I like things to match. The other thing I noticed was these diodes right here are somewhat discolored. I don't know if you can see that on the camera, if the lighting will pick it up, but you notice how they're kind of tarnished. And then you look at these over here, they're very shiny. See the difference? So it looks like this side may have gotten hot. I don't know. But strangely enough, this is the side that has the bad, or that seems to have the shorted transistor on it. So there's a lot of work that's been done on this at some point in time, and we're just going to have to take everything apart and go over it. And to make matters worse, I don't have a good schematic, nor do I have a good service manual. So I have to do a little more research here, because this is going to turn out to be not just a simple find a blown transistor and replace it type thing. So once again, we're into it. You guys ought to be used to this if you watch this channel. It seems like everything that comes on my bench is a catastrophic mess. Other than those two Fisher amps that we just did, those receivers, they weren't too bad. I mean, the one, of course, you would expect to have to do the IF transformers, but and that wasn't really, in all actuality, wasn't terrible. This one here, yeah, a lot of work. So where do we start? Well, I'm going to kind of be rather unconventional with this. I know people like to try to power things up and kind of trace power through. I'm not going to worry about that. I mean, this has to work when it's done. We're going to fix it regardless. So we know that things are not working in it. So the first thing I want to do is I'm going to divide and conquer. I'm going to look at this side first where the power is. This is most likely one of the problems because we know we have a shorted output. Another thing I noticed, let me turn this around a little bit so we can get to it. And let me move the light over here. And you're going to see something here. And then I'm going to... You guys love watching the camera move around, don't you? How I waste your time with that. Oh well. So if you look down here, I think this is what produced the smoke. Looking down here, you could see that one's burned up, and this one here is burned up. And if you go to the other side, they're still good, so we can actually, on that side, you can see they're not burned up. So we should be able to see what those were supposed to be. And my friend who brought this to me is actually right now on the hunt for a good service manual for this. And looking at it again, look at this. This transistor has been replaced on this side. You can see that's different. And on this side, it has one of these little transistors, like a little TO92. See it? And you can see not matched. And then there's this pair here. You can see them. And I've never been a big fan of unmatched, at least the same type transistors on both sides and so forth. Yes, it will technically work, but it just affects so many things. So, because you don't know what the transition frequency is on them, and you don't know if they're used as in a differential pair or whatever, how they're going to affect one another, or if they're used in a current source or something. So, yeah, we're gonna replace that. It also looks like, well, yep, it looks like these drivers have been replaced at some time. You see, there's a Toshiba one here, and all the other 11 more are all Motorola's, and they all look to be somewhat original. And so both channels have had lots of work done. And bottom line is, to make this perform properly, you really have to get everything the same. But before we do that, like I said, I would just like to get the problems repaired first, like the things that are burned up, and kind of baseline it from there. So just doing some spot checks. All of the transistors on both sides seem to be okay. But you can tell on this side, this 10 ohm resistor and this 62 ohm resistor have been replaced, as was this capacitor. And if you look on the same, and that's, you can see where they're located. Now we go over to this side, take a look. The same ones blew out the same way on this channel now. And if you look very closely, I don't know if you can see this. Let's put some light on the subject. You see all that liquid there? This cap vented out and leaked. And I have a suspicion, since they replaced this capacitor, the same thing happened there. So that's probably the main thing that failed. The other thing, if you notice, they have this large TO202 transistor here, and it pairs up with this one right here, so you can see that's kind of not the right complement of transistors. But on this side, you can see they have the correct ones right in here. And you can see right here where they put the transistor package on this side, and then they just left this hole open. And you look on this side, you have the originals in there still. A pair here and a pair here. And I'm going to return this to this. I mean, these are nice, but I don't think it's going to be a problem with this circuit. If it was, SAE would have done that in the first place. There you go. We are going to do some rebuilding, and this was a pain in the butt to take apart a little bit. Not terrible, but I really, as delicate as this board is, and as delicate as the pins are that plug in here, I don't want to take this apart and put it together too many times. So I am going to kind of hedge my bets a little bit and rebuild this board, even though it hasn't been fully tested, before I put it back together. We know it worked for a little while they were testing it out before this part blew up. So it's a good amp. So I don't think it's a problem to rebuild it. So that's what I'm going to do. So I'm just trying to understand a little bit about, how they made this thing, how it works, and looking at the fact that some of these transistors have been replaced, and that there have been failures on both channels at some point in this thing's life. You could see this one currently, which was that, but this channel, the same part of that circuit failed, but the transistor was not replaced. It's original. This one has been replaced with something different. And more importantly, I'm kind of looking at the differential pairs for the input, as well as the current mirrors. And you can see over here they've replaced them with these packaged ones, like I said earlier in the video. And here they're the originals. I just wanted to see how critical the matching was, at least what they used. So I pulled this set of original transistors up here, and I put them in the comparator circuit that I have. You've all seen this a lot of times. And sure enough, these are a very, very closely matched pair of transistors. Now, they're not marked. They don't have the little paint dots on them or anything like that. But I do think that SAE did take the time to match the transistors. So we can see our VBE track right there. And then when we move down here, these little peaks right here represent the turn on and turn off of the two transistors together. And they give us a good idea of how the transition frequency is on each transistor. If they have a really different frequency characteristic, you'll see these things will get really crazy. The other thing is temperature will affect that. So if I put my finger on one of the transistors, it'll actually make these things change. So what this is all saying, being as close as these all are, is these are very well matched transistors. So I'm going to make sure I use matched transistors as well for this circuit. I am going to replace these little domed transistors, and these are actually a really common one. They're a 2N3565, and I've worked with those a lot in the past, and those are pretty well known to get kind of messed up. They'll get noisy or have problems. So, which is probably why one channel had to have them replaced. So I'm going to replace all of them on this board. Every so often I probably need to do this on a video because I get a lot of questions. So here is what a set of unmatched transistors look like. You could see the peak on this side, and it even begins to go negative. This is because of the way that the transition frequency of the two transistors are so different. And you can see that the other side of it goes way off peak. Now, I'll turn the intensity up. You can see it a little better. And you can see here's your zero line where everything's turned off. This is where the transistors are conducting against one another. And you can even see on there that the VBE track is way the heck off. See that? It's really bad because this line and this line should be completely in line with one another, and they're not. Now, you might ask, why is this so bad? Why is this so badly out of, why are they so unmatched? Well, it's because I actually took a KSC 1845 and I put it in with one of the original transistors. So you can see they have different characteristics from one another. However, if you put two together that match, and the reason this one's offset in the socket is because the pinout's different, that's all. So they just wanted them both to be in there correctly. Now if I put this one in, and of course I'm touching it with my fingers, so that'll affect it a little bit. But if we give this just a couple of seconds, kind of fan some air over it, and then we bring this back down. Now you could see the one transistor is kind of temperature adjusting to the other because the one's been in there a while and the other one I just put in. But if we wait long enough, you can see these peaks will start to get very similar. And if we look at the VBE track, you can see they're very close to being in line. And you don't see that negative peak either. So these ones are timed very well together, and their VBEs are very close to one another. So we pretty much know that this is a pretty well matched pair right here. And what you're going to find is you can buy graded transistors like from Mauser and DigiKey. In other words, these are KSC 1845s, but after the 1845 it says FCH. And FCH, all of those suffixes have to do with the gain characteristics and so forth, and sometimes the pinout of the transistor. So what that means for us is you can get ones that are already graded within a gain range, so you can pull any random 2 off of the tape like this, and they'll already pretty much be a guarantee to be somewhat matched. And then if you really want to match them even tighter, you can compare them until you get these to be perfect. So that's what I'm doing. Once we do that, I'm going to get those in. Now you might ask, if putting the 2 different transistors in, if they mismatch so terribly, can we substitute that KSC 1845 for these original 2N3565s? And the answer is yes, you can. As long as your transition frequency and everything and your gain is the same, which I checked just the basic HFE check on this, and you can do it on a curve tracer and get more accurate results, but this little test seems to work well. These will play well together, and they will be a very suitable substitute for these. So you just have to watch the specs. Even though they don't match, you just have to make sure that these have at least a minimal transition frequency the same as these. The other thing that you have to understand when you're picking another transistor is maybe these have way too high of a transition frequency, and that may cause them to, in some instances, to oscillate, to go into parasitic oscillation when these lower frequency ones don't. You have to take all of this into consideration when you're replacing transistors and substituting them. I get a lot of questions online. I'm restoring XYZ amplifier, and what transistors do I replace everything with? Well, that's a lot of research, as you can tell, and I just don't always have the time to sit down for you guys and do that. So that's why I'm showing this to you, so that you can understand what you need to look at and then be able to do that for yourself. You really kind of need to understand how these things work. So anyway, long story short, these 1845s are going to work great, and I'm going to use them in there. The other thing, again, specs, you have to make sure your voltages are good. And these are not a particularly high voltage transistor, and these ones actually are pretty robust. So once again, these are probably actually going to perform better than those original ones. So I replaced these transistors here, and as it turns out, even though these are a lot heavier duty transistors, what were they? MJE 350 and MJE 340 turned out to be a really suitable replacement for the transistors that were in there. You got to remember, a lot of these transistors don't have characteristics because they took the actual names off of the transistors, or the numbers, and they replaced them with SAE numbers. So for instance, they might take a transistor that's a 2N5401, for instance, and they'll just rub off the lettering and they'll put on SAE 50. So you have no idea. And I do have a crossover chart, and I've been kind of adding to it a little bit that kind of shows what some folks out there have crossed these over to, but it's by no means complete. So you have to kind of do some testing. I pulled the good transistors out of this side, and I just tested them and compared them, and turns out that the MJE 350 and 340 were good. Now I'm on to why this thing fried, and it looks like this was the culprit. Took this capacitor out, and you can see it did leak pretty bad. And putting it on the Sencor capacitor analyzer, it's reading over 50% high, and it's reading, it won't even read leakage. The leakage just flashes, almost like a short. So when you put 10 volts, which this is a 10 volt capacitor, it reads as a short. Now, you can't trust these little testers, and I'm going to show you one here. You can get some ideas, but this might actually fool you. So if you just connect one of these little, $10 eBay or Amazon testers that test everything, they're handy. But for an instance like this, for instance, This is a clue that it's reading much higher than 100 microfarads because it's a 100. But the ESR doesn't look terrible. If you notice, it's 0.39 ohms. But you have to remember, this is testing at low voltage. It's not actually putting full voltage on it for leakage. And I know Mr. Carlson has that tester out there. It probably would have picked up the leakage because of the way it works. So that's another thing that might work. But just so you know, you can't just rely on those really cheap testers. They don't always tell the whole story. So I'm going to recap this board. That's the bottom line. Okay, so we're all rebuilt. We got the caps replaced. I put 15-turn pots in there, and I set them to the same resistance that the old ones were. We replaced the caps, checked all the heatsink compound, tightened all that, replaced these transistors as we said earlier, and the current mirrors and the differential pairs. Everything seems to be ready to go. Cleaned up rather nice. So now we can get on to the other bigger part of the amp.